Hello folks, today we need to solve a problem which requires us to return the smallest subtree which contains all the deepest node. So first we need two definitions. Firstly, what is a subtree and what is a deepest node. Here, a node is called the deepest if its largest depth possible among any nodes in the entire tree. So let's take this example. 4 and 7 are the deepest node because the depth or the difference with the root node is the largest here. So if we take this root and if we take this 0, we need 2 steps to reach this 0, but for this 4 or 7 we need 3 steps. Clear, the height or the depth is largest. Okay. uh, yeah. And what is a subtree? We all know what a subtree is. It must not only contain those two nodes, but it must also connect those two nodes. If this and this are the deepest node, then 2 connects both of them. So this is a subtree. Now the first thing that comes to my mind is, what if the root is empty? Okay, there is no value there. Or what if the root is the only root present there? Let's start a bracket. So root dot left would be empty, as well as root dot right would be empty, and root dot right is equal to null. In this condition, what I want to do is I simply want to return the root and nothing else. uh, this might cause a problem. Wait. If root is empty, I simply want to return this, and never mind. What if the root is empty? And because it's a OR condition, it would check for his left and right child. But you know that if the root is not empty, and if it checks for the left or the right child, then we know that we are in for a null pointer exception in Java. Now, the another thing mentioned here is depth. So first we need to create a function which would return the depth of a node or a particular node. Yeah, so it would return a int which would be the depth, and it would take a tree node. Let's call it a node. Okay, now what I want to do is, in depth, if node equals to null, we return 0. And else what we do is we return the max of left and right plus 1. So let's call it max dot max of, I'll call this same function depth on its left child as well as on the right child. So whichever of them is greater, my function would return that, and the value of 1 would be added. So it's a simple thing to find the root. Now we may observe a simple fact, that this is the answer because it has the deepest node as well as it is balanced. So what if the 7 wasn't present here? Then the subtree won't be 2 and 4. The subtree would only be 4 again. What my approach is, I'll be at this root, I'll check the height of 5 and 1, and if the height of 5 is greater than 1, I for sure know this thing, that the deepest node would be present in this 5 in the subtree, in its right subtree. Let's call this as a right subtree, so I don't even have to iterate over the left subtree. Sorry, this is the left subtree and this is the right subtree. So if the height of left is greater than right, I would forget about the right and I would just iterate over the left subtree. Again, same. For 5 I would check for 6 and 2. For 6 it would return 0, and for 2 it would return 1. So now I know where I want to go. I want to go to this 2. In this 2, what I'll do is I'll check for 7, I'll check for 4. It will return me 0 because 0 0. So I know that I need to return 2 as my root. What if 7 wasn't present, only 4 was present? So I would be at 2, then I would check for 4 and for its left subtree, and I know since its left subtree does not exist. Is it a perfect binary tree? So we don't know if it's a perfect binary tree or not. So let's just do this, and if it's not a perfect binary tree, we'll modify our codes. So what I want to do here is, after this if statement, I yeah yeah this too, yeah, I want to create a left which would give me the depth of the roots dot left, yeah, and then I want a right which would do the same with the depth root dot right, yeah. Now what I want to do is, I want to compare this. So I want an if left is equal to right. What I want here is, I need to return the node, the root node. Else if, what I want to check is left is greater than right. If left is greater than right, then we don't care about the left node. We need to return, we need to call this function again. Okay, let's copy and paste for the right, for the left part of the tree, as we did for the 5. And finally else, if nothing happens, then we need to return it for the right. If none of these conditions are true, then we know that the subtree, the right subtree, has the deepest node. Oh man, yeah, I hope I didn't misspell anything there. RIGHT, yeah, and I hope this works. It works here. Let's try submitting. If it fails, it would be the only reason that we don't, if it works. So if it failed, that would mean that we are not given a perfect binary tree. So for this 5, this 6 does not exist. So while we are trying to grab this 6, it does not exist. So that could have been the only problem, but it is a good problem, a decent one. We can solve it in easily. Thank you.